Chapter 12, Lesson 1. And in this assignment, in problems number 1, 2, and 3, we're being asked to write the quadratic function in standard form. So let's take a look at number 2. So the first thing I need to do is to distribute 3x. And what I remember about standard form is that it is in the form of f of x equals ax squared plus bx plus c. So as you can see in number 2, once we distribute, we have our function in standard form. In number 4, I would like you to read this problem, and I'm going to pause for just a minute and let you read through the problem, and then we'll talk about what this situation is asking us to find. So in this scenario, I'm going to place a fence around 3 sides of the new dog park. We're going to fence this side, second side, and this third side. This side right here is going to be adjacent to the existing dog park, which already has a fence, so I don't need to place a fence in this region right here. Already has a fence there, so we don't need one. Now, altogether, I have 1,000 feet of fencing to go around these 3 sides. So what I need to do is I need to determine what the length of the new dog park is. That's this side right here. I need to determine what that length is in terms of the width. So I'm going to start with my 1,000 feet, and I'm going to subtract 1W. I'm going to subtract 2Ws. Now this is what I call the leftovers. All of the leftovers are going to be placed on this third side, which we call the length, 1,000 minus 2W. Those are the leftovers. So if we want to write a function for the area of the new dog park, so when I find the area, what I'm trying to find is, I'm trying to find this entire area inside here. And what I remember about finding the area of a rectangle is I need to multiply one side of the rectangle by the other side of the rectangle. So my area function, A of W, is going to be my width times my length. I need to write this in standard form. So I'm going to begin by distributing. And in standard form, so looking at my function, I notice that my leading coefficient, or my value for A, we look at here my value for A in standard form, right here, this value here, tells me whether I have a maximum or a minimum. If my A value is a positive value, then I know that my parabola is opening up, and therefore I have a minimum. However, if my A value is a negative value, as it is here, then my parabola will be opening down, and therefore I have what's considered a maximum. To find the x-intercepts, I'm going to use Desmos, and I'm going to input this function, and I can actually input any three of these functions, and Desmos will graph all three of them as they are the same parabola. My x-intercept is 0, 0. My other x-intercept is 500, 0. Now, to help me understand what these two coordinates mean in terms of this problem situation, we're going to go ahead and go to part E. We're going to sketch this graph. We're going to talk about what the axes represent and what each value on the graph represents. So along the x-axis, all of these values here represent the width. So if you remember my dog park had a width and another width and then a length. So my width in terms of feet is my x value, and my y values represented the area of this entire region in square feet. To help me to graph this parabola, I'm going to use my graphing calculator, and into my function y of 1, y sub 1, and then I'm going to go to my table, which is second graph, and let's set this up and start at 0, and let's go up by, try 10. So that I don't have to scroll down, I'm going to go ahead and set my table to go up by 50. we can discuss what the x-intercepts are and what they mean in terms of this problem. So my first x-intercept is 0, 0. That means when my width is 0 feet, I have an area of 0 square feet. My second x-intercept we wrote as 500, 0, which means when my width is 500 feet, I have an area of 0 feet. Now, neither of those x-intercepts make sense in terms of this problem because I cannot have an area of 0 square feet. To find the dimensions of the dog park that maximize the area, I need to find the maximum of this parabola. So when I graph this function, I notice that the parabola is not in this window. To help us find the correct window, I'm going to take a look at the graph that we have set up so that we can see that our window goes from 0 on the x-axis to 500 on the x-axis, from 0 to 500 on the x-axis, on the y-axis from 0. And I think if we put in 130,000, we should get a clear picture. And now we can find our maximum. So to do that, I do second, calculate, come down to number 4, maximum. Go to the left of my maximum and enter. Go to the right, enter, and then enter a third time. So my maximum is at 250 feet for my width. 250 feet for my width gives me a maximum area of 125,000 square feet. So this tells me the width, and this tells me the maximum area. So now the question is, what are the dimensions of the dog park? Here we are back again, part D. What are the dimensions of the dog park that would give you the maximum area? So my maximum point was 250, 125,000. So my width is 250. So 250 by, I need a length. So I need to know what length times my width of 250 would give me a maximum area of 125,000. So we can do this a couple of ways. We can go back up here and we can substitute in what our value of W is. And we found our value of W to be 250. So if I replace W with 250, my length would be equal to 1,000 minus 2 times 250. So 1,000 minus 500 gives me 500. So my dimensions are 250 by 500. And I just want to make sure that that does give me my maximum area. So I'm going to check if I multiply 250 by 500. There's my maximum area of 125,000 square feet. To determine the dimensions of the park, if I restricted my area to only 105 square feet, I need to go back to my graphing calculator. And in my graphing calculator, I'm going to graph the equation y equals 105,000, which will give me a horizontal line about right here. And then what we're going to do is we're going to find the dimensions by finding what this width is, and then also by finding what this width is. So let's take a look at leaving our first function and adding y equals 105,000. So my second function, there's that line that we just talked about at y equals 105,000. So I want to find what my intersection point is. And we're going to find the intersection point to the left first. So I need to go and place my cursor a little bit to the left, a little bit to the right, and enter that. And we get an intersection point of 150, comma, 105,000. Now we're going to find this second intersection point. So I'm going to go to the left of that point and enter. To the right of that point, enter. Enter a third time, and that intersection point is 350, comma, 105,000. So one of the dimensions of the park, one of the dimensions would be 150 by 150 by something that gives me an area of 105,000. So I need to find 150 times something gives me an area of 105,000. So to find that value, I'm going to divide 105,000. Divided by 150 gives me 700. So my dimensions are 150 by 700. And then my other point of intersection is 350 by, we're going to do the same thing. Take 100 105,000 and divide that by 350. So those are my dimensions that give me an area restricted to 105,000 square feet. In number 6, we have a builder who is designing a parking lot. And in this particular problem, he has 400 feet of fencing, and he, again, is only going to go around 3 sides of the parking lot. So sometimes helpful to draw a diagram. So here are the 3 sides of the parking lot, and we're going to let X be the width. And so to find the leftover parts for this 3rd side right here, to find the leftover parts, I need to take the total number of fencing that I have and subtract 1x, 2x. So this is the leftover parts for that 3rd side. So as you can see, that this area function came from multiplying one side of the rectangle by the other side of the rectangle and now you can place that function into your graphing calculator to find the absolute maximum using your second calculate, and then to describe what every x and y coordinate represents in terms of this problem situation. All right, in this puzzle, we're asked to find all the missing angle measures. So I'm going to use some of my skills from the 1st semester. For example, I know the sum of the angles in a triangle is 180. So I can find the measure of this missing angle by taking 180, subtracting 40, and subtracting 30, and that leaves me with 110 degrees. So vertical angles are congruent. Supplementary angles are 180 degrees. If this angle here is 90 degrees, then these angles together must also be 90 degrees. And so that means this angle needs to be 50. And if I know this angle is 50, this angle is 70, together that's 120. So that means this angle has to be 60. The sum of the angles in a triangle are 180 degrees. These 2 angles are vertical. And these angles here are supplementary. If this angle here is 90 degrees, then these angles together must be 90 degrees. So that means this angle here is 60 degrees. And angle 90 degrees. I think we have them all. Oh, forgot this one over here. 150 degrees, supplementary angles.